हेलो स्टूडेंट्स। दिस लेक्चर इज फॉर कोलिजन। कोलिजन जो है वो बहुत ही बेसिक चैप्टर है। जब हम फिजिक्स की शुरुआत करते हैं क्लास 11th में, और टीचर बहुत ही मेरी फर्स्ट लेक्चर में वो कहता है दैट द कोलिजन इज नथिंग बट टीचर व्हाट they say about the physics. That the physics is the interaction of particles, right? So physics is interaction of particles. So basically, what do you mean by interaction of particles? That is the things related to the force acting between the particles, right? The momentum, the energy. So this is what the chapter is known as collision. So the foremost useful important chapter collision, and it's a very broad chapter. That is, the collision is there between the particles and particles in day-to-day life, and numbers of collisions. Whatever you do, whatever the interaction, even we walk, there is an interaction between, our foot and the ground. It's all interactions related to collisions. But in some collision, the time duration between the particles come closer. The time duration is very small, and the force acted on each particle, if two particles collide, is very large. Then we say it is an impact. And this kind of collision, where we are talking about impact, that is a large force thing between the particles, or we can say each particles from other, one particle from other, during a small interval of time, and that is impact. And that particular things we would like to discuss in this chapter. So our concern is here is the interaction between two particles when the interval time between them, the time of collision is very small. During collision, what happens? Each particle experiences a large force for a small interval of time. That is, we are talking about impact then. And the large force is called impulsive force. And then there is a useful quantity, impulse, which is the product of this impulsive force over the time, multiplied over the time. Or we can say it is, even this force is not constant, which act on the particle or the body. It's first increases, goes to maximum value, and then decreases and come to zero. So if we want to find the product of the force and the time interval of the collision, we have to integrate. And the integral over the impulsive force over the time is known as impulse. Students, whatever the collision, since if we consider if we see the impulsive force between two particles, colliding particles, then from Newton's third law, the impulsive force acting on particle 1 due to 2 and the particle 2 due to 1 follows Newton's third law of motion. And then the forces are equal and opposite. Then if we consider the two particles together, a system, then net force acting on it is equal to 0. Hence, from Newton's second law, the momentum of the system will be constant. So, in collision, the momentum of the system will be conserved if during collision some external forces are not acting. But if you are considering the two particles, the momentum will be conserved because no net force. Sometimes maybe some internal, energy converted, internal energy changes in terms of converted in terms of kinetic energy of the particles. Even though the internal force, because of internal force, the momentum will not change. So You know, collision or interaction is really important. It is between the particles and particles. It is from, if you think about very small, from at very small range, even a small, smallest particle, if you think there is a collision, that is interaction. That is the interaction at atomic or nuclear level. When we say that, we know the fission reaction, when a slow neutron attack the uranium 235, it create the fission reaction. Lot of energy evolved in this reaction, and the uranium is split into two middle range elements. So strontium or xenon, like that. So, and then in this process again the further neutrons, three neutrons emitted, and then by control process in nuclear power plant, those fast moving neutrons, they slow down, and again it attacks to the fresh uranium atom, and the chain reactions continues, and this energy, this large amount of energy which evolved from this fusion reaction, is used for generation of electricity by heating the water and converted the water to steam, and then it used to rotate the turbine of the generator and produce electricity. So, in nuclear reaction, if I say, you know, there internal energy, binding energy in any nuclear reaction, you see, if the energy is evolved, if it is exergic reaction or exothermic reaction, you know that the one thing is, that is Einstein mass energy relation, that the mass of the reactant is more than the mass of the product, and that difference into c square is the energy evolved. All these things are related to collision. Even the collision between the particle and the body. When we are talking about the particle in the body, then we will talk more about impulse, impact, impulsive force. When we are talking about particle-particle interactions, I am focused more about momentum and energy. So let me think collision interaction in two ways. One is particle-particle interactions, and one is particle-body interaction. Even we can think bodies and body interaction. But let me first discuss about particle-particle interaction. So basically, collision is what? Collision is an interaction between the particles. Right. So collision is interaction between the particles. Let me come to the particle-particle interaction. As I told you that uh, particle particle interaction, and then I will discuss particle and rigid body interaction. So here we will more involved about the impulse, and here we will think in terms of conservation of momentum, the system, and energy. Here also we'll think the momentum, the system, and energy apart from impulse. So let me think first. Let me discuss about the particle-particle interaction. So particle-particle interaction. One moment, student. Okay. Okay. So say this is a particle of mass m1 and moving with velocity v1, and this is another particle of mass m2 moving with velocity v2, right? And let's think that all these particles are moving in a straight line. So let me say that this moving in a straight line, right? And somewhere here the collision took place, right? And after collision, the velocity of particle 1 is v1 dash and particle 2 is v2 dash. See, as we know, during collision, the force acting on particle 1 is F12 and force acting on particle 2 is F21. And we know from Newton's third law, this must be equal and opposite. If I am considering for system, then F12 plus F21 is equal to 0. And then we can say that force on the system is equal to 0. So we can, therefore, we can say the momentum of the system will be conserved. Upon. So now let's apply the conservation of momentum there. All right. So I can write initial momentum m1 v1. I am considering right side to be positive. M1 v1 plus m2 v2 is equal to m1 v1 dash plus. All right. So this is the momentum of the system, and that is conserved. Initial momentum is equal to final momentum. Now let us think in terms of energy. How about energy? No doubt, the total energy of the system is always conserved. No doubt. But if I say about the kinetic energy, then you know what happens during collision. We can think the a moment will come when the both the particle will attain the common velocity, and then their energy, kinetic energy, some part of kinetic energy converted into the potential energy, and when they depart, again the potential energy come to changes to kinetic energy. You can think like that. See, this is a particle 1 and think there is a spring, and this is a particle 2 and think there is a spring. So when they collide, it could collide something like that, and again they depart. So during collision, this spring energy is converted into elastic potential energy, and when it is departed, this spring potential energy again converted into what? Kinetic energy. So here it will be say V1, here it is V2, its mass is M1, its mass is M2, right? And here it could have say a velocity U, both will have the same velocity U, M1, M2, and some potential energy in the system, right? In the spring, or you I can say system. And then again when they when after collision, this is before collision, and this is after collision. Again, this will have the velocity say v1 dash, and this will have v2 dash m1. And so, if the force acting during the collision, if the force during the collision is conservative, if I am talking that is elastic force is conservative, then then the kinetic energy changes to potential energy, and again it changes to kinetic energy, and then there is no loss of energy. right? No loss of energy means no loss of kinetic energy, I can say particularly. So then we can say such type of collision is, if there is no loss of kinetic energy, means K initial of system is equal to K final of the system. Then it is called then it is called perfectly elastic. Means what? A collision in which there is no loss of kinetic energy. See, so I can say one by, if I apply the conservation of energy, I should say the conservation of kinetic energy basically. Or let me write conservation of energy. So I can say before 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square is equal to 1 by 2 m1 v1 dash square plus v1 dash plus 1 by 2 m2 v2 dash square. Means this is the perfectly elastic collision, no loss of energy, initial energy is equal to final energy. And if you solve the problem, if you take any problem and if you solve it, you will get, you will get the value of v1 and v2 from that. So with help of these two equations, this is equation number 2 and this is equation number 1, the momentum, right? We can solve the value of v1 and v2 for any problem because two equations are there and two unknowns are there. All right. So if I say, if I write, if I, so we can get the value, we'll get some value. But now let us think a different situation in which the kinetic energy is not conserved. Means if in I am considering two, it depends on the material of the body. If two objects, suppose particles are made of mud, m1, m2, let moving with velocity, this one is a v1 is equal to v naught and v2 is equal to 0, and it collides. And after collision, they are moving together, and they are moving with a velocity v. The mass becomes, say, m1 is equal to m and m2 is also m, so mass becomes 2m. See, what will be the conservation of momentum you apply? Conservation of momentum, I will write m v naught plus 0 is equal to 2mv, and I will get v is equal to v naught by 2. If I see the energy k initial, kinetic energy, if I say, it will be 1 by 2 m v naught square. And if I write the final kinetic energy, it could be 1 by 2 2m into v square, that will be 1 by 2m into v naught by 2 square. And this will be m v naught square by 4. So m v naught square by 4. So what we said, that's a mud ball and it stick together after collision, right? So kinetic energy is lost. So there is a loss in kinetic energy. And what is the loss in kinetic energy? K initial minus K final. That will be this minus this, and this value will be how much? mv naught square by 2 minus mv naught square by 4, that is mv naught square by 4. Means K initial minus K final is greater than 0. It means I can say K initial of the system is equal to K final of the system plus Q. So this energy is, converted in the form of this kinetic energy which lost is converted in the form of heat energy, maybe sound energy, maybe light energy, or maybe the elastic potential energy which is permanently stored in the system. So, give me just one moment time. Because I have one call, please. I'm really sorry. Just give me one moment. Yeah, yeah. What? आप बताइए। पावर हो गया। हो गया। Hello friends, really sorry I took your time. Let me continue the lecture, please, for some time. Okay, let me continue. तो हम हम जो है वो इस बात की डिस्कस कर रहे थे बच्चों कि वन मोमेंट, हम इस बात को डिस्कस कर रहे थे दैट कि ऐसा होगा कि यदि कुछ एनर्जी लॉस हो जाए, कोलिजन जो है जहाँ की काइनेटिक एनर्जी, इनिशियल काइनेटिक एनर्जी लॉस हो जाए, एंड इट that energy will, what will happen to that energy? That will convert in the form of kinetic energy, yes, sorry, heat energy, sound energy, light energy, elastic potential energy, जो deformation permanent हो गया. So what we see that, most of the collision is this kind. There is some loss of energy, right? In day-to-day life, whatever we interact, we see, there's some loss of energy. And then this collision is known as inelastic. अच्छा, आपने देखा होगा एक बॉल हम ड्रॉप करते थे और उसकी सरफेस से टक्कर के बाद और ऊपर चली जाती है, ऐसे केस में तो काइनेटिक एनर्जी फाइनल बढ़ जाती है. You know, in that case, there is also the example of inelastic collision, but it is then super elastic. Super elastic. Inelastic collision means what? Here, K initial system is greater than K final system. And super elastic means what? K final of the system is greater than K initial of the system. Yes or no? So, there is a difference between inelastic collision and super. So, super elastic, you got it that after collision, the kinetic energy increases. And you know, with many common examples, like you have seen in Diwali, you just when you जब पटाखे जलाते हो तो क्या होता है जब बॉम्ब यूज करते हो it goes in the air split into many fragments and its energy will be so high, it got kinetic energy, it got some light energy or heat energy. तो उसकी एनर्जी शुरू में तो है नहीं, लेकिन that internal energy converted into kinetic energy. So what happens? Final kinetic energy is much more than initial energy, and that is even we can understand that in nuclear atomic and nuclear reaction, like the fusion process, uh, when slow neutron hits strike the U-230 uranium 235, it split it into two middle level elements, right? Like krypton, xenon, like that, or iridium, like that, or strontium. So what happens? The kinetic energy of the product is so high, very high, and why this? Because then the internal energy is converted into kinetic energy, and that is we. It's a very great that we everyone is it is very well known that it is from Einstein mass energy relation that mass converted into energy means the mass of the reactant is more than the mass of the product, and the difference into c square is the energy that liberated in this process. you know one nucleon of uranium, one nucleus of uranium 235, when it extracts when with the neutron, it is split into two middle range elements, and it gives 200 mega electron volt of energy. You can understand that 235 by 6.023 10 to the 23, that much gram of uranium. So a small quantity is giving 200 mega electron volt. So that is also a kind of super elastic. It's not super, it is a nuclear reaction. In all such reaction, if I say inelastic here, the normal cases, what I told you that Q is for inelastic. Let me say for inelastic collision. We should very clear, the loss. There is a loss of kinetic energy. Loss of mean no internal energy here is converted. Understand now? It is just a particle interaction. वो पार्टिकल इतना पास नहीं आ गया कि वो कोलम्बिक फोर्स जो है, कोलम्बिक जो रिपल्सन है दो पार्टिकल के बीच, न्यूक्लियस न्यूक्लियस के बीच में, उसको ओवरकम कर जाए और न्यूक्लियर लेवल पे आ जाए और न्यूक्लियर बम्बार्डमेंट हो जाए. तो उसकी बातें यदि नहीं कर रहे, मैं पार्टिकल पार्टिकल इंटरेक्शन की बातें करूं और आपको बता दूं जब पार्टिकल पार्टिकल होता है तो कोई टक्कर नहीं होती है. Because of Coulombic repulsion, they have some minimum distance, and then they deviate from their initial path. I will come to that also. Means though we are saying it after collision it is moving in a straight line, and then after collision moving in a straight line. It's not the thing because there is no well, yeah, it may be the head on, and typically it will one return back, recoil back, and another is moving like this. Yes, it is possible, but generally there will be a particle deviated from the initial path because the collision is basically when it comes closer, there is a large repulsive force act and it deviates. So in inelastic collision, there is loss of kinetic energy. right? Loss of kinetic energy, right? And then K initial of the system minus K final of the system is equal to Q energy loss, right? And if I am talking about super elastic or atomic or nuclear interaction, here no doubt K final is much greater than K initial generally, right? And then here we measure the Q value of the reaction, or in physics we can say interaction. In chemistry it is what reacts. So the Q value is basically what, how we measure. See, if we get energy here, just we are taking the reverse, Q value we are saying K final of system minus K initial. So we should not, it should be very clear. This is I'm talking about at nuclear reaction. We are saying when the internal energy is converted, right? For that case, we are talking the Q value is what, K final minus K initial. और ये एनर्जी आता कहाँ से? That is from Einstein mass energy relation. That is equal to mass of reactant minus mass of reactant mass of product into. So this is what the Q value. And if I say that what happens in case of uranium in the fission reaction, if uranium U235 is converted into say strontium and xenon, something like that. Let me take its value 193 or something like that, its value. Let me take one problem. Strontium, see here, strontium 97 and xenon 138 and 117 mega electron, right? So something like that. So if I say strontium plus xenon and 97 and 130, one moment please, student. It's a little slow now. 97 and 130. Let me write. And 170 mega electron volt. Then suppose the total energy is converted in the form of kinetic energy of strontium and xenon, then what will be the kinetic energy of strontium and xenon? Again we can say this energy is converted totally into this kinetic energy, this 170 mega electron volt. So if I apply the conservation of momentum, then I can say conservation of momentum, initial momentum 0 is equal to 97 u mass into velocity of strontium plus 138 u plus velocity of xenon, right? That we can say. And from energy we can say, and these two momentum must be equal and opposite, right? So from energy we can say energy total will be P square by 2 this 9 2 into mass of, I can say 97 U, mass of P square 2m plus P square by 2 into 138 U. So if I say the energy of strontium, it will be, it could be here P square by 2. This will be 1 by 97 U plus 1 by 138 U, right? And the strontium will be what? P square by 2 9 into 97 U. To put the value of this is how much? This is given 170 mega electron volt. So P square will be 2 into 170 into 97 U into 138 U upon 97 U plus 138 U into 2 into 97 U. So 2 into 97 U, you cut this thing. So you will have total energy 170 into 138 U upon 97 U plus 138 U. And similarly, the energy of xenon will be 170, this is mega electron volt, into reciprocal, right? So it will be how much? 97 U by 97 U plus 138 U. So whatever its value, right? So this is what the energy. Now here what we say that Q in this reaction, the Q value is 170 mega electron positive. Q value is greater than 0. And such reaction is known as, such interaction is known as exoergic, or in chemistry we know uh, exothermic. We say exothermic reaction. So the exoergic interaction is what? The Q value is positive. Very low initial energy is needed, and this reaction is, we get the lot of energy in the form of product. So this reaction is also spontaneous. So this reaction is spontaneous because exothermic reaction is what? Spontaneous, because lot of energy involved in this reaction. But in atomic at nuclear level, if I am talking the Q value, in some reaction, it is not possible unless you give some energy. Means the Q value is less than 0. Means what? The K final of the system is less than K initial of the system. I am talking about this atomic and nuclear level. Then this reaction is known as endoergic or endothermic. And then you have to supply the energy to make possible that this reaction should take place. And the very common big example is what? Fusion. You know that at Sun, deuterium and tritium, these two particles fuse together. Why? Because it required lot of energy, initial energy, which cannot fuse otherwise. Because this is what? An example of endoergic reaction. It fused together because the temperature of sun in the order of 10 raised to 7 Kelvin and very high density, almost 150 times to that of density of water. And then this reaction takes place continuously, and these two, deuterium and tritium, is fused and form a single nuclei, helium, and plus then the energy. So If generally what happens, when this is the particle 1, say mass m1 and velocity v1, and moving with some other particle m2, generally the other particle is known as target and its velocity is 0. After collision, the particle m1 is moving with velocity v1 dash and this m2 is v2. Even I can say that, I can say in a better way that the particle 1 is moving like this. This is the particle 1, this is the particle 2, and particle 2 move like this. This is V2 dash, and this is what E1 dash, and this is a line of initial line, and this is deviated through an angle theta 1, and this particle 1, which was the target particle, is deviated through an angle theta 2. Say this is mass m1 and this is mass m. Generally the particle, so there, you know but still the momentum is conserved, so the plane, they are moving in the different direction after collision, and this plane of the collision is known as plane of scattering. This plane is known as plane of scattering. It is scattered. If you gone through in chemistry the Rutherford experiment, they have used the metal foil and then fast moving, helium particles, and then they scattered. Some particles will, take very few particles will take the U-turn 180-degree, right? And most of them are scattered. So same thing happens at atomic level, they scattered. But here my what I would like to tell you that, there you have to supply, if Q is negative, then you have to supply some energy to make this reaction possible, infusion reaction possible, and that is known as threshold energy. Threshold energy. Threshold energy is the minimum kinetic energy of the bombarding particle. This is the particles to hit the target particles and produce, you know, the fusion reactions should take place. Because what should be what should be the energy required for this reaction to possible? We know that here this reaction to possible, what happens, K final, K initial is more, K initial minus K final is equal to Q in this case. Or even I can say, if I say K final minus K initial, I will minus Q, because I'm talking about which one? Endoergic reaction. What I am saying that the kinetic energy of reactant product is more. Then kinetic energy of initial should be Q plus K final. Or let us write always the mod Q, because it must be the Q value, right? So kinetic energy of should be equal to initial kinetic energy for such reaction, endoergic reaction, must be equal to Q plus K final, means K initial must be greater than equal to, right? I can say minimum it must be greater than, because K final can be anything. So K initial, the reaction to happen, the minimum value of K initial minimum is what? Q value of reaction. The Q value of the reaction is basically in this reaction, in fusion reaction, this is reaction take place like this. This is the target element A. Sorry, this is the bombardment elements A, and this is the target element B. Target, let me say target, and this is the energetic particle. Energetic particle. Basically, it is what bombardment. And then it A is going, and after this, the collision, it could be like this something. All right, then we get something. Maybe we are getting some C or D, something like that. So we can say in this reaction, A plus B, it goes to C plus D. If I am writing in this fusion reaction, or even I let me write only C if they fuse together. So let me write only C plus some energy, and that energy is what, minus Q. And if I am writing in terms of its value, minus Q, so this is what we have written here, K initial minus, because what is Q? Q is that this is what, K initial, and this is K final. So what I told you, that this is K initial is more than K final, but Q value, what we said, K final minus K initial. So this is minus Q something. But then what is the K initial? K initial minimum value required for such fusion reaction to take place. If I am saying such fusion reaction to take place is what, mod Q, Q value of the reaction. Then what we can say, if I write, in terms of momentum conservation of momentum for such reaction, I can say the P momentum PA, momentum of particle A, and momentum of particle B is 0, target at rest, and then momentum of combined particle C, that is what, C is basically A and B together. I can say A plus B. So if I write the energy, then we can say in terms of energy, I'm not saying the kinetic energy, I'm saying energy, then K initial is equal to mod Q, right, plus what is the final energy, that will be what, P square by, right, momentum is same, so P square by 2 mass of C, that is mass of C is mass of A plus mass of B. And what is the kinetic energy minimum required for this reaction to happen, or see, this is if I want to find this. So kinetic energy initial is nothing but P square, same P, same P, same P square by 2 the mass of A, because P is the target, no energy. So this is equal to this value. And then if I bring this side, it will be P square by 2 MA. Don't write MA, P square by 2M. It will be what? 1 by MA minus 1 by MA plus M, and is equal to mod Q. So student, you are understanding, this is what we are doing for endothermic reaction or endoergic reaction. And then it will be what exactly, P square by 2 MB by MA plus MB into MA is equal to mod Q, the Q value of the reaction. Then we can write P square by 2MA is equal to MA plus MB by MB, target mass of the target, into mod Q. And P square by 2MA is what? Just we have K I minimum. This is very important. So minimum kinetic energy, minimum Ki minimum is known as minimum kinetic energy of the bombardment particle required to fusion reaction, fusion or endoalgic reaction take place, and it is also known as it is also known as threshold energy. Threshold energy. So I can say the K initial minimum is basically K threshold, and this will be what? P square by 2 MA. And you must remember, for such reaction to happen, the threshold kinetic energy must be equal to MA plus MB by MB into. I hope student you got this thing. जब भी फ्यूजन रिएक्शन की बात हो तो कितना थ्रेशोल्ड एनर्जी चाहिए रिएक्शन होने के लिए, तो दैट विल बी Ma प्लस Mb इंटू क्यू. तो यदि मैं बोलूं कि मान लीजिए ये A है और ये B है, ये टारगेट है और ये एनर्जेटिक पार्टिकल है, बॉम्बार्डमेंट पार्टिकल्स है, देन और इससे जो है C मिला प्लस कुछ एनर्जी मिली, जो एनर्जी निगेटिव होगी दैट विल बी से 10 मेगा इलेक्ट्रॉन. So what is the threshold energy of A required to make this reaction possible? Then my suppose mass of A is 2U, 2 mu, and mass of B is say 18 AMU. Then I can say the K threshold will be Ma plus Mb, that is 2U plus 18U upon mass of B, that is 18U into 10, right? 10, this is mod, right? So I can say this will be 20 by 18 into 10 or whatever its value, right? 9 by 10. So 100 by 9. So something around 11 mega electron volt energy required for bombardment particle A so that this reaction take place. So you will get many problems in nuclear physics or in collisions to reaction the possible. So this is what I have discussed, the endoergic reaction. And exoergic reaction or exothermal reaction, is spontaneous. The in fission, the slow neutron produces, which extract the U-235 uranium 235, and the fusion take place. Only thing, further it will give three fast electron neutron, and it again strikes the uranium U-235, and the chain starts like that, and we have to control it. Otherwise, it will be the atomic bomb. If it is uncontrolled, if it is controlled, then it is used for power plant for energy production. Alright, students. So now, this is what I have discussed you about the collision. So just I brief you this thing. First, I said the particle-particle interaction in which if I remove this, take out the nuclear level, atomic level, then क्या होता है? एनर्जी जो इनिशियल एनर्जी है, काइनेटिक एनर्जी, वही फाइनल यदि हो जाती है तो परफेक्टली इलास्टिक बोलते हैं. और इसमें क्या बोलते हैं कि जो फोर्सेस एक्ट बिटवीन द पार्टिकल्स आर कंजर्वेटिव, इलास्टिक कंजर्वेटिव फोर्स, एंड देयर इज नो लॉस ऑफ एनर्जी. लेकिन यदि फोर्स जो है परफेक्टली कंजर्वेटिव कंजर्वेटिव फोर्स नहीं हुआ, या फिर एनर्जी, इनिशियल एनर्जी जो है वो फाइनल एनर्जी के बराबर नहीं हुई, कुछ एनर्जी लॉस हो गया इनिशियल, तो हम क्या बोलते हैं, इसको इन इलास्टिक फ्यूजन बोलते हैं, जो डे टू डे लाइफ में जो भी इंटरेक्शन होती है उसकी बातें करते हैं। मगर जब हमने ऐसा भी देखा है कि जब बॉल किसी बॉल को गिराते हैं, उससे ज्यादा, जिस हाइट से गिराते हैं उससे ज्यादा हाइट चली जाती है, तो हम लोग बचपन में खेलते थे, उसको हम लोग क्या बोलते हैं, सुपर इलास्टिक। और सुपर इलास्टिक कहीं ना कहीं रिलेट करती है कि भाई एनर्जी ज्यादा भी हो सकता है, the energy of after interaction, the even energy can be more। और जब ये बातें हम करते हैं तो ये बातें फिर आ जाती है एटॉमिक और न्यूक्लियर लेवल पे, जहाँ की डेफिनेटली एनर्जी ज्यादा हो जाता है इन इन फ्यूजन रिएक्शन, और जहाँ एनर्जी ज्यादा हो जाता है आफ्टर इंटरेक्शन, देन वी से इट इज एक्सोएनर्जिक रिएक्शन। और जहाँ पे एनर्जी चाहिए होता है रिएक्शन को पॉसिबल करने के लिए फ्यूजन में, तो वहां पे हम थ्रेशोल्ड एनर्जी निकालते हैं, और उसकी वैल्यू क्या होती है, द मास ऑफ bombardment particle plus mass of the target divided by the mass of target into the q value of the reaction is the threshold kinetic energy required to make such reaction possible। बच्चों, तो यहां तक हमने किया। आइए हम पार्टिकल पार्टिकल इंटरेक्शन में हम पर्टिकुलर केस डिस्कस करते हैं जो कि परफेक्टली इलास्टिक है। वी आर टॉकिंग अबाउट द इलास्टिक कोलिजन इन पार्टिकल पार्टिकल इंटरेक्शन। अभी मैं इन इलास्टिक की बात छोड़ देता हूँ, आई एम नॉट डिस्कसिंग इन इलास्टिक की बातें मैंने कर ली जो रिक्वायर्ड थी। अब मैं आता हूँ परफेक्टली इलास्टिक कोलिजन की बात करता हूँ पार्टिकल पार्टिकल इंटरेक्शन में। राइट, तो आई एम टॉकिंग पार्टिकल पार्टिकल interaction, and I am talking perfectly elastic collision। तो अभी तक क्या कर रहे थे भाई, अभी तक हम परफेक्टली इलास्टिक भी किए, इन इलास्टिक भी किए, और इन इलास्टिक में हमने वो भी केसेस लिया जहां की एनर्जी जो है, इंटरनल एनर्जी, बाइंडिंग एनर्जी जो है वो कन्वर्टेड इनटू काइनेटिक एनर्जी। मतलब मैंने न्यूक्लियर रिएक्शन की बातें कर दी। बट अभी जो हम कर रहे हैं पार्टिकल पार्टिकल इंटरेक्शन पे, कोई न्यूक्लियर और एटॉमिक लेवल की बात नहीं कर रहे हैं, तो न्यूक्लियर की बात नहीं कर रहे हैं, हम पार्टिकल पार्टिकल इंटरेक्शन कह रहे हैं जिसमें कि कोई इंटरनल एनर्जी बाहर नहीं आ रही है। राइट, जो काइनेटिक एनर्जी इनिशियल था वही काइनेटिक एनर्जी फाइनल भी है। मगर क्या यहाँ पे हमारी बातें डिफरेंट क्यों है, कि क्या कोलिजन के बाद, इंटरेक्शन के बाद पार्टिकल सेम स्ट्रेट लाइन में जाती है? देन द क्वेश्चन इज दैट नो, पार्टिकल नॉट मूव्स इन द सेम स्ट्रेट लाइन आफ्टर कोलिजन। द पार्टिकल्स डिविएट, if you see, in true way, in right way, the particle deviate from their line of approach, or initial line of, line of collision, if I say the, or initial velocity vector. Since it is a particle, then I can say from the velocity approach, the direction of velocity approach is something, and after collision, it goes in different directions. So let me discuss you exactly what happens in collision particle particle. This is m1 moving with velocity v1, right? And this is m2 moving with velocity v2. It collides here perfectly elastically, and then even let me draw this thing carefully here. This is m1, and right, and then it collides and it goes something like this. Let me take a simple understanding that V2 is 0. Make this thing for you. This is the target that it is. Then this V2 will, after collision, is going something like that. And V1 is going something like this. In fact, because of electrostatic repulsion, this is not possible, right? If these two collide, they can come close to each other. They can come close to each other, but they can never go within, certain distance. This is the minimum distance these two particles can be come. If I say here little magnified diagram, one is going like that and two is going like this. So this is the minimum distance between them. That is the approach. Minimum, minimum, minimum distance of approach. And then one particle is going in this direction, other is going in this direction, and this plane in which these two particles moves, this is called the plane of scattered. It is a scattered, basically, a scattering. So this moves, suppose an angle theta with the initial line, the particle 1, and this moves with an angle theta 2, right? Particle 2 moves at angle theta 2. Then, yes, we can apply the conservation of momentum and we can write, if I apply the conservation of momentum, I can say m1 v1 is equal to, initial second particle is 0, is m1 v1 cos theta 1 plus m2. And then this is what happened. And then m1 v1 sine theta 1, no doubt, m1 v1 sine theta 1 minus m2 v2 sine theta 2. Initial momentum in y is 0. This is in along x and this is along y. If I am talking this about x and this about. Alright, students. So this is what we can write the momentum. And what we should write for energy. If I write for energy, I will have conservation of energy, since this is perfectly elastic collision we are talking about. So this will be 1 by 2 m1 v1 square plus is equal to 1 by 2 m1 1 dash, let me please correct it, v1 v1 dash v2 dash v1 dash v2 dash v1. All right. 1 by is 1 by 2 m1 v1 dash square plus 1 by 2. So this is how we will get this thing. We have, but here if you see carefully, what are the unknowns here? Here the unknowns are v1 dash, v2 dash, theta 1, theta 2. So, and we have three equations, right? All right. So, if you try to solve it, right, how you will solve? There are three equations. All right. Can we see the same problem, in center of mass frame, right? Center of mass frame, this problem is something, look, it will be simple. If I say this is the momentum, center of mass frame, we have to see this problem. It's quite simple. It will be more easy, good to understand this problem, right? To understand this problem in center of mass. Let us do the same problem in center of mass. Okay? Problem collision center of mass. This is what from the ground frame. What we have written from the ground frame, right? So I can say lab frame or ground. Now let us write center of mass frame. To understand center of mass. So what is the velocity of center of mass? Velocity of center of mass is m1 v1 plus m2 v2 by m1 plus. We can write m1 v1 is m1 v1. This is 0 because this is a target particle we have considered. This is it. So let me write the velocity of center of mass is what? M1 V1 by M1. So from the center of mass frame, what is the velocity of 1 before collision? E1 C, if I center of mass frame, this is what the velocity of particle 1 before collision from center of mass frame, right? So center of mass frame, the velocity of particle 1 before collision from center of will be what? E1C, E1 minus BC, right? So I can say that could be E1 minus M1 V1 by M1 plus M2. So today it's running. So M1 V1 is out, so it is M2 E1 by M1 plus V1C, right? And what is the velocity of 2 in the center of mass frame? V2C. V2C will be, so I hope you understand this thing. This is 1 V1, this is V2, the velocity of center of mass, and this is V1 dash, this is V2 dash, right? So we will do this thing. Let me calculate first. So V1, V2C is what? V2C is 0, V2 minus VC, and this will be 0 minus V, and this could be minus M1 E1 by M1 plus. So this is the velocity of 2 which is to center mass before collision. Alright. Now let me say what is the momentum of the particle 1 before collision P1. P1 is equal to M1 P1C, and that will be M1 M2 V1 by M1 plus M. Alright. Now what is the momentum of particle 2 in center of mass frame? So this will be M2 into V2C, and this will be M2, M1 is minus M1 V1 by M1. So if I say this to be P, then I let me say this will be in the center of this is P, then this will be what? Minus P, right? So the momentum from center of mass frame, both the particle will have equal and opposite momentum. In center of mass frame, particle 1 having momentum P, then particle 2 having momentum minus P. Such that the diagonal line. So the momentum of the system is equal to what? 0. So both will have equal in magnitude, the momentum having equal in magnitude in opposite direction. So in center of mass frame, net momentum is 0, and both particles will have equal and opposite momentum before collision. Let's see what happens after collision. So after collision, momentum of the particle 1, what is the velocities after collision, right? Same thing, that could be E1, and we can say E1, we can write P1 is equal to what? A P1 dash Cm is P1, or let me write from that. Let me first calculate after collision what is the velocity of center of mass. Velocity of center of mass will be M1 V1, just let me write the vector, plus M2 V2 by M1, right? Because directions are different. And then here, if I say what is the velocity in center of mass frame, then it could be E1 cm dash will be what? V1 dash, right? This is V1 dash minus DC, and this will be V1 dash minus VC is what? M1 V1 dash plus M2 V2 dash by M1 plus. And then if I solve, I will get M1 V1 dash is cancelled out. Then it will be what? M2 V1 dash minus M2 V2 dash by 1 plus. Or I can say it will be M2 by M1 plus M2 into what? V1 dash V2 dash. Let me charge little bit of its pencil. So what I got, student, the velocity of particle 1 after collision is V1 dash minus V2 dash, all having the vector sign. So we should not miss the vector sign, even the directions are different. So V1C dash we are talking about after collision. Right? So, so you should be very careful, what we are doing here. We got one thing we got here before collision. Check कर लो, let us check it. Before collision, I got the momentum. This is P1C. If I say carefully, then this could be V1 and this is P. Then P2C is minus P. Right? And if I write the vector form, yes or no? Because it is in initially it is in one direction, so I took like written like this, but it's fine. So now you can understand the velocity after collision क्या हो गया ये आपने समझ में आपको आ गया. Now one more. Let me little get charged this one. Right. All right. See. So similarly, if you say that what is V2C, let me write V2C. Student, same way you do it, you will get what? M1 by M1 plus M2 V1C minus V2. V1 dash minus, right? Same thing you will get. You will get uh, minus of that, I hope, because it will be V2 minus, this could be what? V2 minus this. And when I say V2 minus this, then this could be, uh, this could be, here it could be V2, then M1 V2 minus M2 V2. So this M2 V2 is out. So it could be M1 V1 M1 V2 dash minus, so it would be minus sign will come. So this will be the minus sign, right? So student, if I write the momentum of particle 1 with respect to center of mass frame after collision, it could be what? M1 M2 by M1 plus M2 into what? I can say V1 dash plus is what? V relative dash. V relative dash. And this we know, I can say M1, M2, M1 is mu. I write by mu er dash. Mu is what? Relative reduced mass system. Mu is called what? Mu is called reduced mass system. In the center of mass frame, we are considering two bodies together as a single particle. Two particles together, single particle, and its mass is M1, M2 by M plus M2. And similarly, the momentum of second particle in the center of mass frame, I have to multiply this this with m2, right? Momentum of particle 2, I have to multiply here m2. So what I will get? M1 m2 by m1 plus m2, minus sign only. This thing is same. So this could be what? Minus mu into e related dash. So what we got? We are getting what? P system is zero. Particle in center of mass frame, momentum of each particles are equal and opposite. Only thing that this time it will be different direction. So let me understand this thing carefully. What is the momentum of one and momentum of two equal and opposite? But what is the direction? What is the initial direction, students? Let us come. Initially, it is m1 moving with velocity v, and this is m2 coming. It was zero. Velocity was zero, and after that, this is m1 moving with velocity. This angle is theta 1, and velocity is v1 dash, and this is m2. This angle is theta 2, right? And this will be what? M2, and this is V2 dash. So what we see basically, that P1 with respect to center of mass frame is mu m. What we got it here? P1 what I got? P1 I got this, and again this I can say what? This again I can say mu into V relative, right? And this I can say minus mu into V relative. Here V relative is V1 minus V2, and V1 is V1 and V2 is 0. So this is equal to V relative is V1. So student, if you carefully, if you will see, what you will find, the initial momentum is mu into V, a particle 1 V relative. VR stand for relative. Let me write here VR for V. That is what? V1 vector minus V. Right. Alright. So this could be V minus 0. So vectorally it could be P1 says this. P1 says this. And P2 says what? P2C we got minus V relative. Means this could be this. And after collision, it will be what? P1C dash you got mu V relative dash. V relative dash is basically what? V relative dash is basically V1 minus V2. So V1, this is V1, V1 dash, and this is V2 dash. So V1 minus V2 is something like that. So V2 minus, so it could be like this if I draw it. This is V1 dash minus V2 dash. Student, you should be careful, right? This will be what? V1 V relative. This could be V relative dash. Yes or no? So this is V relative, and this is the direction of mu into V relative is what? This is the direction of what? P1C. Am I right this thing? And then P2C is what? P2 dash C, means momentum of second particle after collision is minus mu into E relative dash. So P1C is this, then P2C just opposite to that. This is what? P2C. So student, let us draw it like this. Before collision center of mass frame, the momentum of the particle before collision was like this. P1C, P2C, and after collision it will be what? P1C dash, and this could be, let me read, just opposite, right? Equal and opposite in magnitude as well. Length should be also equal. P2 dash. So this, the vector are equal and opposite in center of mass frame. Means the angle through P1C is rotate or turn. This is, I say, phi. Then the same angle the P2C will turn is what? Phi. And this is in center of mass frame. Whatever the angle turned by each momentum vector, means momentum of one or momentum of two are equal, and this is known as angle of scattering. It's known as what? Angle of scattering. So scattering, this is the nature of collision. It depends on the mass of the particles. Let's see, if I take carefully, this is what V1 dash C. If I say, um, this is what V1C, V1C dash, this is VC, right? And this is V1C, V1. This is, let me draw V1. What is the V1 basically? V1, this is V1. Let me say V1 dash. Let me write this way that what you know that if V1 dash is equal to what? VC plus V1C. Yes or no? VC plus V1 dash C is equal to what? V1 dash. Means this angle V1 dash C is this. This is what? V1 dash. And this is what? V1. This is V1 means what? With respect to ground frame. And this angle is what? Theta 1. Right? This angle is theta 1. The particle 1, particle 2, and it is going here, it is going here. This angle is theta 1, this angle is theta 2 in the ground frame. So this theta 1, but the VC, what angle it will turn? The VC is in direction of P1C, right? So VC will not change, right? The VC will not change because in the collision, VC vector will be constant. Yes or no? There is no external force acting on it. So before also BC was like this. Before collision, after also it will like this. BC plus V1 dash C will be what? V1. And VC is this. And V1 dash C is this. This angle is what? Phi. So this angle is what? This angle is phi. So you can relate the theta 1 is what? Angle of deviation. Theta 1 is what? Angle of deviation of particle 1 after collision. And similarly for particle 2, theta 2 is for same thing for particle 2. Right. All right. So this is what you now what we can relate The V1 dash, this is the velocity in the left frame, right? And this is the velocity of center of mass, and this is the velocity in the center of mass frame of particle 1. This is the velocity of particle 1 in center of mass frame after collision. This is what we are writing after collision. After collision only there is a scattering and there is a deviation. So this is what we have relate after collision, right? This thing. So if I use this parallelogram law, then you have gone through, you can write tan theta 1 is equal to what? This upon this. Yes or no? Tan theta 1 is this upon this. So what is this? V1 dash C cos sine phi, right? This is V1 dash C sine phi. You can write this is V1 dash C sine phi plus Vc plus V1 dash C cos phi, right? So remember here, phi is the angle of a scattering. This is the angle to which the momentum vector of each particle rotate in center of mass frame after collision. And both the particle 1 and 2 will rotate the same scattering angle phi. But in ground frame or lab frame, these deviations are different, theta 1 and theta 2. So lab frame things are very simple, easy. So tan theta 1 is like this. And we know Vc, just to be got it, Vc is equal to what? M1, we got Vc and V1 dash